Welcome to Brain Vision.
Okay, here we have a disk that's rotating with angular velocity initially of 0.1 radian per second. The angular acceleration is 2 times the position theta. And we're looking for the angular position of this point A at time t equals 2 seconds. We're going to have to do a little bit of calculus here in order to find this position. So first, we note that our alpha was given to us in terms of theta and not time. So we know we can write alpha as the time derivative of omega. But of course, we can multiply that by d theta, and we can do a little bit of a trick here to rewrite this as d omega d theta times d theta dt. Well, we know this d theta dt is just omega, and we know alpha is just 2 theta, so we can rewrite this then by multiplying both sides by that d theta as 2 theta d theta equals omega d omega. So at this point then, we can take the integral of both sides. On the left side for theta, we take the integral. So we have 2 times the integral of 0 to position theta of theta d theta equals the integral from omega naught, so the initial omega to the final omega of omega d omega. When we take the integral of both sides, that leads us to, on the left side here, we get a 2 theta squared over 2, so that just gives us a theta squared. And on the right side, we get an omega squared minus omega naught squared over 2. So we can multiply both sides by 2, of course, and solve for that omega. So to do that, I'm going to move back up to the right here. So I draw an arrow just showing that. We have omega equals the square root of omega 0 or omega naught squared plus 2 times theta squared. We can rewrite omega then as d theta dt. So that's now d theta dt. And we can move the thetas to one side of the equation and the time to the other side of the equation. So when we do that, we have a dt equals d theta over the square root of 2 theta squared plus omega 0 squared. We can then take the integral of both sides, and we'll have to be fairly tricky with this integral. You can either look it up or use something like Mathematica to solve it, but we end up with a t equals 1 over the square root of 2 times the natural log of, let me make sure I carefully write this down here, theta plus the square root of theta squared plus omega over the square root of 2 quantity squared. And that's still under the square root here. And then we divide that by omega 0 divided by the square root of 2. So now what we'd like to do is solve this equation for theta. And there'll be a lot of algebra involved for this. And then we'll put in the time of 2 seconds in. But once we go through the algebra, Well, which I won't do right here because it's a little bit tedious to do, but I would encourage you to go through that on your own. We would find that we have theta equals omega 0 over 2 times the square root of 2 times the exponential of the square root of 2 times t minus the exponential of negative square root of 2 times t. When we put our time of 2 in and our omega 0 of 0.1 radians per second in, we get a final position here of 0.596 radians.